And now I would like to introduce to the stage Finch from Penumbra.
Hello. So, today I want to talk about this thing that we've been calling full stack private protocol design. All right, so I'm from Penumbra Labs. This is our logo. It's the best that I can do, drawing it by hand, because I decided to draw my slides by hand because I thought it would be fun to do. So I'm from Penumbra. Those of you who don't know what Penumbra is, I'm just going to give a really quick overview so that I can ground the talk and chat about some of the cool stuff that we're doing. This talk is going to be a bit of a grab bag, and I think that's going to be really fun. But the grab bag has a theme, and I will introduce the theme momentarily. But first, so what is Penumbra? Penumbra is a Tendermint L1 app chain written in Rust. We have shielded transfer, staking, governance. As Zaki was just saying in his talk, all of these operate on a model that is different from the Cosmos SDK, which means that interoperability is kind of an interesting question. I was just having some cool conversations about private interchain accounts and how we can make that work with the Penumbra model, which is not an account model under the hood. It's a UTXO model, like Zcash. Accounts from the user perspective are sort of a polite fiction presented by the client interface. But that's sort of an aside. Also, we have IBC, to and from anywhere. And so you have this interchain shielded pool that Penumbra gives you in the Cosmos ecosystem and beyond. As well as in the center of that, a shielded DEX that uses a lot of the really cool privacy features that we've built in Penumbra to get some really unique features of a DEX, stuff you couldn't build without privacy in that environment. And I actually give a talk about that at Gateway on Sunday morning, very first talk slot of the day. So some of you may not have seen it because you were asleep. And that's fine, because it's recorded and it's on YouTube already. So you can go look it up and watch it. And I encourage you to do so. It got some good reviews. So this talk is about three things. When you're building a private protocol and you want it to be used by people, like actually used, you want it to be faster, easier, and cheaper than everything that has come before. Because if your private protocol is slower, harder, and more expensive, then no one is going to ever use it, regardless of how much they care about privacy, except for weirdos like me, right? So, and probably quite a few of you, but we are weird, right? We're not the norm. So I want to talk about this. This is a shitpost that I made recently. I was talking to the Penumbra group chat that we have inside the company, and I had this like little brainworm. I was thinking about some of the different architectures that we have in Penumbra, and I realized that we've got these different structures that represent different parts of our flow. So we've got something called a transaction plan, which you can use your human intent and what we call the view service to construct. And then this gets turned into a transaction. So the plan is like the plain text version of a transaction. The transaction is the encrypted version. Then once you submit the transaction to the chain, what you actually look at once you pull it back down from the chain is a transaction view, and then sort of hypothetically, you could translate that back into a sort of abstract representation of the human intent behind that thing. And I realized this 4-element cycle looks exactly like this thing called an OODA loop. And those of you who are not familiar with an OODA loop, it was this idea that got invented by some guys in the Department of Defense or something back in like the 1960s or something. Don't quote me on that. But there are a lot of memes about this. There's this very funny Twitter account called Defense Charts that sort of posts declassified slides from Department of Defense briefings that look like absolutely insane PowerPoints on drugs. And so like I sent this to the group chat and everyone was like, this is a great shit post. We should post this on our alt account, which is called Penumbra Devs. And so we did that. And then I started thinking about this and realized this is actually not just a shitpost. This is actually kind of an interesting way of thinking about the way that private systems work. This is an example of what we call shitpost-driven development. And it turns out shitpost-driven development is actually a really great way to figure things out for real. Because when you're shitposting, you don't restrain yourself to just thinking in a sort of like orderly and straightforward manner. You let your mind just cast out for associations. And oftentimes what that means is that you realize that there are certain symmetries that manifest as jokes, but are real. And when symmetries are missing, you realize that there's something missing in the design of your system. So I am like full-heartedly and unironically in favor of shitpost-driven development. I encourage you to try it out. And I will see you on Twitter when you do that. So anyhow, this OODA loop, I'm going to talk about sort of all the different components of this flow and how when you when you're constructing a private protocol like Penumbra, you have to think about how to make it faster, easier, and cheaper. Not just at one part of the flow where, say, perhaps you're processing a transaction on the node, but also where you're viewing a transaction on the client, or you're planning a transaction on the client. Like there's this whole loop that goes from the client to the node, and then back again, maybe through a relayer, does all sorts of stuff, right? Okay, cool. So faster. And this is where we get into the grab bag stuff. Most clients, most of the time, they're not sending transactions, actually. And I gave a talk about this at ZK Summit 8, which has some pretty cool visualizations that I did not draw by hand, but wrote a computer program to generate. So you can watch that with more details about this. But they're actually doing private state sync. That's to say that when you have a ZK system, you can't just query the chain, of course, to find out what your balance is. You need to download the entire history of every transaction that's ever happened. And you need to decrypt it locally. You need to synchronize a shielded commitment tree in order to get the root hash so that you can prove inclusion of all of your state fragments, right? So this is slow and hard because you have to hash everything from the beginning of time into now. So we didn't want to do that. Instead, we built this optimized, tiered, accelerated Merkle tree that we call the tiered commitment tree. That's what my talk is about at ZK8. But we also realized that this isn't enough because fundamentally, even though this solves the computational problem of not having to compute every hash since the beginning of time, you still have a bandwidth limitation problem because you still have to download every transaction since the beginning of time. So we built into Penumbra some cool cryptography to do fuzzy message detection for private delegated scanning. So what this means is in your key hierarchy, you have a particular subkey that's called the detection key. And the detection key is something that you can hand off to a third party, not a trusted third party, but just any third party, and say, hey, can you please scan probabilistically for all of my transactions? And that party will hand you back a set it's like an encrypted Bloom filter. So that party hands you back a set of, say, 10 times more transactions that are actually yours. And then you locally filter those down. And the third party can't tell the difference between the transactions that are yours and the chaff that's generated. So it still more or less protects the metadata privacy of the transactions that you're doing because the third party doesn't know which is you in the restricted stream that it's filtering out of the fire hose. But you get to download only 10 times more data or whatever, like a factor of 10 I'm just sort of waving my hands about, as opposed to the entire fire hose. And that's really cool. And that means that you can take even better advantage of the optimized accelerated Merkle tree that we have so that you can just zip right ahead and synchronize your entire state so that you can use the wallet on your cell phone or something like that. All right, so. But sometimes also you don't just want to know how much money you want to have, you want to actually send that money somewhere else. Weird, right? So we also want to make this fast. So we realized that when you are authorizing, when you're constructing a transaction, you're sort of doing two things at the same time. You are proving the transaction, you're forming a zero-knowledge proof, and you're producing the witness data that's necessary to create that proof, but you're also authorizing the transaction by signing it. Now, signing the transaction is a pretty quick thing to do computationally. The proving actually takes quite a lot of time, by which I mean like less than a second for a lot of our Penumbra transactions, but still, yeah. So, but you're also authorizing the transaction. And so what we did is we said, well, do these things concurrently. We architected things so that you can have a concurrent authorization flow, which means that you have the user say use their ledger device to authorize the transaction, and they simultaneously in the background you're doing all of this work on the computer to prove it. So that gives you more responsive UX. Okay, so easier, right? This goes back to the OODA loop that I had up there before. Intents, we're all talking about intents, right? This is not necessarily the intents that everyone else is talking about, but we do have this notion now of a transaction intent, and we want to build that so that we have like an easy representation of what does it mean to want to do something in a private context. Because these transaction plans that I've been talking about, they're the plain text of a transaction, but they contain all sorts of stuff like references to which notes you're spending, and randomizers, and ZK, not ZK proofs, but like you've got all of this like extra chaff that doesn't really represent actually what you're trying to do. It sort of represents like the implementation details. So instead, you want to be able to have a data structure that says, you know, I want to send like 10 USDC to ZKValidator because they're doing a great job organizing this conference, or something like that. And that's all, right? And then you want to be able to translate this into a plan so that this helps developers to write better interfaces so that they don't have to manage like actually building these transaction plans and scanning through note data and all of this stuff. But it also helps users to have a more comprehensible understanding of the contents of a transaction. So what about advanced users? What about advanced biddlers, right? So we've built the Penumbra state model in a kind of interesting way. So internally, we've got this way that we've got a copy on write state model. That means that when we are internally within the application, we're making modifications to the state. We don't actually commit those changes down to the underlying storage. What we do instead is we hold them in memory, and we've got like a layered stack of modifications. We can fork the state, we can do arbitrary things to it, and then at some point we can decide to commit it down. But if we don't commit the state all the way down, that means that we can actually just use the exact same mechanism to offer an RPC that says you can query a full node and ask it, what if I did this? What would happen? And it can give you a hypothetical answer about what if you did that transaction using the exact same transaction logic and validation stuff as if you actually submitted the transaction. Which means that for people who are doing like trading bots and stuff like this is actually like really useful. Okay, cheaper. Fees have to exist because we don't want people to be using up all of our network bandwidth, right? So we need a fee model, and there's this cool paper about multi-dimensional fee markets that we're going to be implementing on Penumbra. It's very cool. But we need a specific fee model within that kind of paradigm that's tuned for a zero-knowledge chain like us. In particular, we want to place a premium on any actions that contribute to the stream of things that you have to download when you are synchronizing your client state, because we want client sync to be fast. So as a consequence, we're going to charge more for actions in your transaction that don't just bloat the state on the full nodes, because full node operators have a bunch of resources, but actions that bloat the state that you actually have to download as a client, because clients don't necessarily have a lot of resources. But we realized that every Penumbra transaction is actually secretly, or not so secretly, a micro ZK rollup that consists of, well, the micro ZK rollup, that's to say the commitment and zero knowledge proof of a single transaction. We're rolling up a one transaction into one tiny little commitment to it, and also the encrypted contents of said rollup. And we thought to ourselves, well, why do we need two? Well, we need two because we want any client that has their seed phrase to be able to recover the entire contents of all of their state. And we also need the recipient of the transaction to be able to decode the notes that they have been sent. But what if you're keeping track of all of your own state off-chain, and what if the recipient is always yourself? So that's actually like a pretty reasonable scenario. That scenario happens a lot if you're doing a bunch of market making actively, because that just consists of like opening positions, closing positions, claiming rewards, all of this cyclically to yourself. So what if you could keep track of your own state and you don't, and you're only sending to yourself? Then you don't need to publish the encrypted data to the chain. You can just use Penumbra as a like micro ZK rollup chain for all of your trading activity. Well, that would be great, but you also need a way to durably track your own state. Because you don't want to lose that state, which means that you would make it unspendable. Like if Penumbra isn't holding all of your state, then that means it's not just if you lose your seed phrase, you lose access to your funds. It's if you lose your entire database of all of these tiny state fragments, which seems a bit scary, right? Because it's a lot easier to back up a seed phrase than it is to back up like a database that's in motion. So we're building Narsal. Narsal is a private or like a permissioned personal custody chain for Penumbra. It's based on Tendermint consensus, and what it lets you do is it does threshold keys. You do like threshold signing using it. You split your signing key across all of the shards of your Narsal cluster, so that when you want to submit a transaction to Penumbra, you submit the transaction plan for your Penumbra transaction to the Narsal cluster. It does and that is a transaction in the Narsal blockchain. And what it does is it signs the transaction and it gives you back the signed transaction for you to then submit to Penumbra. And that means that everything that you do on Penumbra using the key that's distributed across your Narsal cluster is itself tracked by the Narsal blockchain. So this is kind of an example of like, blockchains are useful for things even in a less adversarial environment. Like some people are like, oh, well, you don't need a blockchain for just keeping track of a database. You could just use a replicated database. Well, this is actually quite a useful replicated database. And so we just are going to use Tendermint consensus to keep track of all of the shards of data. And so you get threshold signing and you get keeping track of your private data, and as a consequence, what you can do is save on sending all of the encrypted bits to the Penumbra blockchain. So if you're an active market maker and you use this thing, you save everybody's work downloading all of your private state that they don't care about, and you save your own fees because you don't need to pay for the block space to store the encrypted blobs that you're storing locally in your own Narsal cluster. Right, so full stack private protocol design. How hard could it really be? Well, just do this. Think about all the bits. Trace all of your data through this. Think about how to make it faster, easier, and cheaper. And draw the rest of the Ouroboros. Thanks.
Thank you very much, Finch. Maybe there are some questions.
Yes, questions.
Anybody?
Yes.
I have a question that I wonder what's the practice content that you need to be approved by witness during a transaction, such as for instance, for the Zcash protocol, it managed to hide the transaction amount and the identity of the sender and the receiver. But according to your presentation, your protocol seems to manage to hide the whole transaction, the whole content of the transaction. So how to do that?
Can you repeat the last bit?
What is the what part of the context of the transaction you need to be putting the witness of the zero-knowledge proof?
Oh, I see. So when we're witnessing things, the stuff that we're witnessing is the zero-knowledge inclusion proof within the shielded commitment tree. So commitments to the existence of notes that you possess. So that's in spends. It's also in swaps, and in governance.
Oh, okay. So the commitment tree is consists of the hash value of each coin or some part or some unit of the.
You're proving that you have custody of a node.
Custody of the node. A node. You mean which node? The node of the Merkle tree, or?
It's yeah. So you're proving that that a particular note did get included in the Merkle tree, in the shielded Merkle tree. Yeah,
okay.
That's right.
Okay, I got it.
This might be one for offline, but as soon as I'm very interested in Penumbra using, interacting with other chains and using interchain accounts. I think I may have incepted Henry to push this forward. But the resource estimation seems like it's going to be very challenging. It's maybe not an issue now because it's all subsidized, but you're doing all of this work to multi-dimensional fee markets to kind of estimate the resource consumption within Penumbra. Mm-hmm. You kind of have a limitation that you don't want to call out to any clear text chain to understand the resources consumed there. Mm-hmm. What is the end game there if you want to interact with other chains and actually be able to estimate how that's going to be paid for?
Well, you're the one that incepted Henry to do that, so let's chat afterwards.
Yeah, let's do that.
But that's a really, really good
fault.
question, and I'm super curious to figure it out. I do think we can do something there, but I don't know the details yet.
Any other questions? Okay, thank you very much, Finch.
Thank you.